Welcome to HS 1.1, Functions of the Mouth and Esophagus and Associated Diseases. Right, so let's look at the gross function of the mouth, esophagus, and salivary glands. Well, when you start digestion, the food first of all goes into the mouth. What do you do in the mouth? Well, you chew it, which is called mastication. The purpose of that is to increase surface area for digestion. What also happens in the mouth? You lubricate it using the saliva and the mucus produced by the goblet cells. And you also produce salivary enzymes, salivary amylase and salivary lipase, which is for carbohydrate and fat metabolism, which is the beginning of digestion. Once the food's gone from the mouth and the oropharynx to the esophagus, well, what happens? It passes down the esophagus, so the esophagus is a conduit, which is a passage, and it moves down by peristalsis. So now let's look at the salivary glands in a bit more detail. Well, first of all, what are the salivary gland secretions? Well, salivary glands secrete three things. As I mentioned, they secrete enzymes, amylase for carbohydrate digestion, and lipase for fat digestion. They secrete mucus, with the purpose of which is cytoprotection, which is to prevent the mucosa damage, mucosa being the innermost layer. Lubrication of the bolus of food to allow it to pass down more easily. Hydration, which is to keep the mucosa moist and prevent cell death. And these are the three functions of the mucus. And the mucus, as I mentioned, is produced by the goblet cells shown here. The next salivary gland secretion, so we've covered enzymes, we've done mucus. The next one is antibacterials. And the salivary glands produce three antibacterials that you need to learn. First of all, you've got immunoglobulin A, which binds to the antigens. You've got lysosome, which causes cell lysis. And you've got lactoferrin, which binds to iron, which I'll talk about in a minute. And these three are immunoglobulins. They help with the immune function. They're antibacterials. So the salivary glands produce three things: enzymes, mucus, and antibacterials. One thing to talk about here is Sjogren's, shown here, with the arrow and the cross. Obviously has a negative effect on salivary glands. It actually attacks the salivary glands, but I'll come on to that later. So let's look at the salivary glands in further detail. Well, let's look at the structure. Salivary glands are exocrine glands because they secrete the enzymes. So the exocrine structure is quite similar to the pancreas actually. You've got the acini at the bottom, which is the acinar cells to produce the enzymes. And then pass up through the ducts, which is lined by duct cells. The duct cells, they modify the secretions of the acinar cells, and there's also some goblet cells, which is part of the duct cells, which secrete water and electrolytes. So the salivary gland structure, you've got two cells essentially. You've got acinar cells, which produce enzymes, and you've got duct cells, which produce water, and they secrete electrolytes to modify the secretions, to change the composition. And the ductal cells also include goblet cells, which secrete mucus. Mucus, as I mentioned above, it's for cytoprotection, to protect the mucosa. It's to lubricate the bolus, and it's to hydrate the mucosa to prevent cell death. So the glands themselves. Well, you've got three salivary glands going from posterior to anterior. You've got the parotid gland, which is antero-inferior to the ears. You've got the submandibular gland, which is the base in the mandible, and you've got the sublingual gland, which is the base of the tongue. The salivary glands, so I mentioned there's parotid, submandibular, and sublingual. The parotid gland is innervated by cranial nerve 9, the glossopharyngeal. It produces serous saliva, so that serous means watery, so it's watery, and it makes up 20% of the total salivary gland secretion. The submandibular gland is innervated by the facial nerve, and it produces mixed saliva, which has some viscosity, and this makes up 70%, so most of the total secretion. Sublingual glands is also innervated by the facial nerve, and it produces mucus, so it's very, very thick compared to the ones that are more posterior. So it's very viscous. It makes up the least, it makes up 10% of the total. Total being 1.5 litres every 24 hours. It's quite a lot of saliva. So we can look at each of these separately. So first of all, let's look at innervation, going from sort of as we move from the parotid to the submandibular to the sublingual, so kind of moving closer to the mouth if you think about it. Innervated by the glossopharyngeal, furthest back, And as you move closer to the face, it's innervated by the facial nerve. So face is facial nerve, and further back parotid is the glossopharyngeal. You can do the same thing with the the secretions. As you move away from the mouth to closer to the mouth, like this, the secretions change. So it goes from watery to thick mucus. And again, Sjogren's attacks the salivary glands, and the mumps virus, which I'll also talk about in a minute, attacks the parotid glands, causing parotitis. So as I mentioned, the salivary glands have an immune function. They produce three things. They produce immunoglobulin A, lactoferrin, and lysosome. So let's look at each of these in turn to see what they do. Well, immunoglobulin A is like the main one. The immunoglobulin A antibodies bind to the pathogenic antigens. And when you bind to the pathogenic antigens, it's gonna block their attack, obviously. And then what happens is that the immunoglobulin A is taken up by M cells, which stimulates lymphoblasts, causing a positive feedback mechanism by which there's more immunoglobulin A secretion. So that's immunoglobulin A. It binds to the pathogens. Next one is lactoferrin. Well, lactoferrin is obviously got ferrin in the title, so it's to do with iron. What happens is it binds to iron, so bacteria can't use it. Well, why would bacteria need iron? Well, iron is important. It is necessary for the cell cycle regulation. So if bacteria don't have iron, then they can't proliferate. So you've got lactoferrin, it binds the iron, so bacteria can't use it, they can't proliferate. The next secretion, so immunoglobulin A and lactoferrin, is lysosome. Lysis obviously splitting, so it attacks the bacterial cell wall, causing cell lysis. Immunoglobulin A also has other immune methods apart from just binding to the antigen. It blocks the sort of bacteria from attacking cells. It binds and neutralizes the toxin. It also opsonizes bacteria. Opsonize meaning holes, punching holes in the walls. As I mentioned, it's taken up by M cells in Peyer's patches, which is the lymph, the immune sort of patches, to stimulate lymphoblasts to have a positive feedback to make more immunoglobulin. And also, it activates natural killer cells.